Good afternoon, everyone. I want to welcome you here to our Bitcoin Innovation Mining Summit today. My name is Jason Ward, and I have the honor of leading the blockchain incubator within Fidelity Center for Applied Technology. And within the blockchain incubator, we're focused on bringing outside research into the firm, educating and inspiring Fidelity associates, and also working to build new products and services. And we're very excited to talk with folks today about sustainability and innovation in the Bitcoin mining area. Let's set the context. Fidelity Investments, large traditional financial services firm. People have come to know that Fidelity is interested in digital assets. Well, the Fidelity journey started back in 2015 through a research and development effort that had us starting out mining Bitcoin. And we entertained this type of activity for a few reasons. We wanted to understand the potential for cryptocurrencies and blockchain technology. We also needed to understand the network security and network economic components so that we could understand how this emerging technology may influence our world in the future. We've come to realize that there's all types of innovation happening in this space, whether it's around hardware or different energy sources. So the speakers that you're going to hear from today represent some of the most forward-thinking companies in the world. We sincerely hope that you will find this day both informative and inspirational. It's my pleasure to welcome Thomas Pacchia to the stage. Thomas will be representing Hash Function and Stronghold. He's a Fidelity alumni as well, but I think one of the interesting things about what Thomas is going to share with us is his journey and his experience looking into different aspects of energy utilization and how it's being deployed in the mining space today. But Thomas, in addition to having been one of the Fidelity blockchain incubator at the time, Bitcoin incubator employees, was also an early employee of Digital Asset Holdings Company. And Thomas has been a derivatives lawyer at Cadwalader, Wickersham, and Taft. Holds a finance degree, master's in finance from NYU Stern School, as well as a JD from the Washburn University School. Thomas also has a Bachelor of Arts from Trinity College. And it's my pleasure to welcome Thomas up to talk to us about Stronghold and Hash Function. So thank you.
All right. Thank you. It's really nice to be back. So I'm Thomas. I run Hash Function, which is a risk management platform focused on Bitcoin mining operations that are looking for ways to sort of hedge out a myriad of volatility risks that are embedded into hash rate that they're otherwise completely exposed to. We've been focused on the space, on the mining industry in particular, since about 2019. And our developments since then have led us in a number of different directions that I'll touch on. But this talk is going to be mostly focused on Stronghold Digital Mining. I'm on the board of directors for Stronghold. It's a mining operation with two power plants based in Pennsylvania. Both of these power plants are powered by waste coal, which is a byproduct of the coal industry that has been sitting there for generations. And it's horribly toxic. It's a Superfund site, effectively, that's just been sitting there, and no one's really dealt with it for a couple of different reasons that I'll touch on. But through Bitcoin mining, we're driving massive efficiencies for these power plants to remain in operation and continue to remediate this mess that's just otherwise polluting communities. So in some ways, I think Stronghold is one of the only environmentally beneficial Bitcoin miners that are out there in terms of its continued operations, and the way it's generating power and using that power is actually cleaning up a disaster. We'll jump around a little bit with the slides. I'm not a super linear thinker, so I might have to go backwards and forwards. But this is a couple of, it was an athletic complex, soccer fields, things like that. This used to be a waste coal location. It's Russellton, Pennsylvania. It's about an hour or so north of Pittsburgh. And one of the main power plants for Stronghold, Scrubgrass, which is another maybe 45 minutes north, has been pulling waste coal from this location. So I want to, perfect. So just to sort of level set some of the definitions, the the perspective, the point of view that I have for mining might help explain why I think Stronghold's approach is so impactful and actually sets them up for long-term, success and viability as a Bitcoin miner. Bitcoin mining operations are competing in one of the most intensely awful industries on the planet. It's just soul crushingly difficult to survive multiple halving cycles. And we're starting to see that now. We're on the back end of one of the, I think, longest and greatest golden eras for mining operations, depending on where you're located, globally speaking. But this cycle seems to be repeating again. At a basic level, electricity goes into special computer, creates hash rate, a computational commodity, a distinct digital asset, an ephemeral asset, which is then refined or converted or produces Bitcoin. We can use different terms depending on who we're talking to describe that process. But everything that is produced from these computers, that computational commodity, is the revenue generating side of a Bitcoin miner. Everything before that is the cost side. So at Hash Function, what we focus on is how to mitigate volatility risks on the revenue side, which is a very, very young industry. We have rudimentary swap and derivative products, but for the most part, we'll focus on the cost side because that's really all miners are able to do right now, is focus on getting those costs as low as possible and as efficient as possible to set them up to just sort of weather storms that they're unequipped, frankly speaking, to deal with on the revenue volatility side. So next slide. Looping into what makes mining so difficult, just focusing on the hard asset side, the real world side of things. We have PPAs, purchasing the power, sourcing the power, electrical engineering, construction, data center construction, data center maintenance, sourcing the hardware, sourcing the right hardware, keeping it happy at good temperatures. It's very good to be in Sweden for keeping a lot of this equipment happy. Keeping dust away from it. Just a number of things can go wrong, and this is all before these computers are even hashing in the first place. Next slide. So this is what I was referencing before. This is sort of the golden era of Bitcoin miners. If you were plugged in and maintaining operations and hashing through a lot of this volatility, in yellow here we see the cumulative network hash rate. In orange is the market. No, sorry, I had that backwards. In yellow is the market price of Bitcoin. In orange is the difficulty adjustments for the cumulative network hash rate, and we can see that fall off. So miners that are not able to maintain operations, China, Kazakhstan, given geopolitical issues, they come offline, and other miners end up benefiting from this, right? So when a mining operation is producing hash rate, they're all competing for their pro rata share of the Bitcoin that are released as rewards. A block subsidy and then the cumulative amount of Bitcoin transactions per block. So maintaining hash rate and increasing it over time is really the name of the game. If a miner is not growing their individual operation at the rate the overall network is growing, they're being diluted, and over a long enough period of time, they die. Even if market price is helping them survive, it'll catch up with them, and effectively they have to drop out and competition couples them. The biggest input that miners have to look at is the cost of electricity, source of electricity, the consistency of that electricity, because with the hardware itself, we can maximize efficiency of the energy that's going in. It's the terahash per joules that an individual miner is able to create. But on the whole, it's by far the largest cost. And it also factors into the uptime. Mining operations need to maintain uptime to get the most amount of efficacy out of each individual ASIC. So a successful and sustainable mining operation over the longest period of time is going to have to drive a fair amount of efficiency on the cost side, particularly when it comes to their source of power. A million things go into this: regulatory, geopolitical considerations, sustainable situations. But the mining industry on the whole has migrated to North America for a number of reasons. We have some of the best legal and capital markets infrastructure on the planet that help operations get a little bit more comfortable with setting up shop here. But there's an abundance of cheap energy. And a lot of that is either wasted or stranded. So we were talking earlier about Hive's approach to wasted and stranded assets. Another wasted asset is waste coal, which brings us back full circle to Stronghold. So waste coal is, could we do next slide? Waste coal is, in ESG terms, a four-letter C word that makes people horribly uncomfortable in the energy space, but it's not coal. It doesn't create more coal. It's a byproduct that's been sitting there since the late 1800s and throughout the 1900s. It goes by many different names up until the 70s, when the Clean Air and Water Act and lots of other environmental regulations were put in place. Coal companies were just creating this stuff and leaving it next to the neighborhoods that were ultimately mining coal from the ground. As part of that, they created a network of waste coal power plants to remediate the Superfund sites that they had created. And these things are gigantic. So you can see some of the stats in the bottom here. We're talking 184,000 acres that just look like the surface of Mars on fire. And neighborhoods border all of this. So this is what I wanted to go back to from the first slide, where we show, you know, a nice new AstroTurf soccer field. But this is what it looked like before. The network of power plants that were created to deal with the waste coal that was left there ended up having a different issue. So in the 80s, 90s, and early aughts, a lot of the industry that was demanding electricity from these power plants, think of like the steel industry, had left Western Pennsylvania, Ohio, West Virginia, Kentucky. So no electric demand ends up putting too much pressure on the power plants. They go bankrupt, they stop remediating the waste coal, and it just sits there. One of the important things to know about waste coal in particular, it pollutes the land and the water just by its mere existence. Rain comes down on top of it, the water table is contaminated and gets worse and worse over time. But it just smolders and catches on fire as well. So these are uncontrolled fires where the coal is burning anyway and then just released into the atmosphere. So it's a bad situation all around. We want to be able to pump these through the specialized power plants to contain some of the fine metal particles and other, you know, horribly toxic elements that are embedded with them. So if we do next slide, and then this is the great work. So these are the two facilities currently owned by Stronghold. One is in Western Pennsylvania. The scrub gas facility is about hour and a half, 2 hours north of Pittsburgh. Panther Creek is close to Jim Thorpe, closer to like Scranton. But a lot of these waste coal facilities are just, you know, scattered throughout like Rust Belt down into Kentucky, and there's just no shortage of power assets to continue operations so long as there's enough demand for the electricity. Next slide. So that's Stronghold. In terms of turning on and turning off a coal-fired power plant, takes months. So we've recently seen these problems as far as the nuclear industry is concerned. In Germany, it takes years to turn on and turn off these facilities. With a coal-fired power plant, it's a little bit better, but it still takes a fair amount of time. So you have sort of this load balancer in the form of a Bitcoin mining operation, effectively a financial battery that you can install on site and maintain operations and get the benefit of the electricity that's being produced where it's otherwise wasted and just becomes a massive inefficiency for the power plant itself. Leading into sort of like a vertical integration for a mining operation. When you have another way, circling back to the earlier point, another way to think about driving efficiencies across a mining operation is not just cutting costs, it's creating efficiencies across the entire stack. So having the operation at the power plant itself, rather than having to have sort of scattered for flared methane in particular, which I think is the next talk, not to dive too much into that. Having sort of a concentration of the facilities drives a tremendous amount of efficiencies as well. And then some stats on the environmentally beneficial use cases that Stronghold is pushing forward.